Okay, Precalc AB students and Mr. Morris here. This is 2.4 day 2 notes. There is a problem above this in the posted notes that I'll have on Canvas. Just later, I'd like you to read that problem. It's very similar to this one. It just has a little more difficult algebra, all right? So in this problem, it says at what point? So at what point, and that's going to be important. So we're going to find an ordered pair. Is the tangent to f of x, which is 3 minus 4x minus x squared, horizontal? So right away, a couple keys to this problem is we're looking for an ordered pair. The other thing is if I have a horizontal tangent, anytime I graph a horizontal line, its slope has to be 0. So the formula over here, which we're using, we're setting it equal to 0. And that formula is the limit as h approaches 0 of f of x plus h minus f of x all over h. This formula here is used to find the slope of tangent lines. Now, in the past, you have used it where, the recent past, where we gave you an x value, you plugged into this formula, and that gave you the slope of the tangent of the graph at that x value. Here we're going backwards. We know we want the slope to be 0, so we're going to set our equation equal to 0. What we're looking for is the point on the graph in which, if we were to graph the tangent there, it would be horizontal or have a slope of 0. So right away, we're going to go to our formula, f of x plus h, and we're going to apply that function notation to f of x, which has us simply plug in x plus h for this x and x plus h for that x. All right? So what that means down here in this next step, so I'm going to actually change highlighters here as we go. So this 3 is part of f of x, so that's that 3 right there. And then minus the 4, this x plus h got substituted in for this x, minus this x plus h got substituted in for this x, and then that is squared. All right? So the next step then is the minus f of x. So that is simply just taking our function f of x and plugging it in right here. So subtract f of x. All right, now the other component to this is it's all divided by h. So really 3 main components. All right, and so the rest of this is a lot of algebra. So from this step down to here, again, you always write proper notation, set it equal to 0, write this every time, the limit as h approaches 0. From this step right here, the 3 is just dropped down. We're going to distribute the negative 4 over the x plus h, which is these two terms right here. And then right here, a couple things. From this step right here to here is the x plus h was FOILed, x plus h squared, so x plus h times x plus h, and then this negative was distributed over those terms. And so that's this right here. All right, and so that takes care of the first part, or the algebra on the f of x plus h. All right, this step right here. All right, all we are doing here is distributing this negative all over all 3 terms. So this next step, simple algebra, but make sure you distribute the negative over each term or the following step will not work, right? Carried through the h. All right, so this step right here is just crossing off like terms that have same value, opposite signs. So this 3 cancels with this negative 3, negative 4x with the 4x, and then the negative x squared with the x squared. All right, and so all that is just canceling. Now, in that step, in that step, you should notice that a lot of things cancel. And then what this next step here is it's just getting down to simplifying that with the terms canceled, not written. All right, so 0 equals limit as h approaches 0 of this, which again is just a repeat of the step before without the canceled terms. Right now, all the way through this process, and I'll talk about this here, is remember when we're actually finding limits, the goal is to eventually be able to plug in this 0 here as h approaches 0, just like any other limit. If we would have tried this in any steps, including the start step or steps previous to it, you would end up with 0 over 0. Anytime you end up with 0 over 0 in a polynomial, that means you should be able to factor out a common factor in the top and bottom, causing you the 0 at a particular value. In this case, it would be at that 0. And so from this step down to here, all we're doing is notice you have an h in each terms in this green highlighted step in the numerator, you have h in each term, and so the h factors out as a awesome GCF. And so this is what's left inside after you factor out the GCF. Now what's cool about that is the h in the numerator and the h in the denominator will cancel. That will allow us to write the next step and then evaluate the limit. All right, I'm just highlighting this. Don't forget to bring down your notation. So after we cancel these h's, right, you have this right here in which you plug your 0 in for your h. In previous steps, we could not because you would get 0 over 0. And now it's really nice because the h in the denominator is canceled. Now we did right over here, must show these steps. You still have to show the steps previous to this, but sometimes students get, try to, get a little quick with their work and maybe save some time. And so make sure you're showing all these steps and don't skip any of them. So from here over here, you'll see a nice little transition. We're going to plug in 0 for h, or plug in h equals 0. Now notice, from here down, I don't have the limit written anymore. And that's because once you evaluate the limit in this step right here, you're taking 0 and plugging it in for h. Once you do that, you are done evaluating the limit, and so the limit should not be written. So the 0 drops the h out, and then we're just left with this next step, which is 0 equals -4 minus 2x. All right, so this step right here, this -4 minus 2x actually represents the following. If I was to choose any x value I wish and plug it into this x, all right, forget about the 0 for 1 second. If I plugged in any x value here I wanted, it would give me the slope of the tangent to my original curve f of x at that x value. All right, that's what we have done in our previous notes. All right, in the last couple days. All right, now in this problem though, we're looking for the x that creates this horizontal tangent or a slope of 0. So that's why this is working how it is. So the next couple steps, fairly easy. Just add the 4. A little algebra here, and then divide by -2, so x is -2. And then finally, since we're looking for an ordered pair, we want to find f of -2 to find its y-coordinate. So you go back up to here into f of x, and into x you plug in -2, which is here and here. And then when you simplify that, you get the 7. And so the tangent to f of x is horizontal at the ordered pair, x is -2 and y is 7, and that completes this problem. Okay, so now I've scrolled down to the last problem. So this example says an object is dropped from a tower which will follow this equation. So the wording here is a little strange. 100 minus 4.9 t squared meters after t seconds. How fast is it falling after 2 seconds? All right, so this is actually going back to problems from previous notes in which we know the x value, or in this case the t value, and we want to find how fast it is going. And that actually means find the instantaneous rate of change or the slope of the tangent to this graph way up here when t is 2. So we're going to go back to here. Now, let me talk about units here real quick. We're in meters, and then t is in seconds. All right, and so the numerator is going to be your distance, or meters, and your denominator is time, which will be seconds. And so you're dividing meters by seconds, and so like speed should be, it's going to be some form of distance over time. So it's meters per second will be the units in our answer. All right, so m here and this m stand for slope, not meters. All right, so we're going back to our formula where the limit as h approaches 0. And in this case, it's f of 2 plus h minus f of 2. So in the previous problem, we were looking for the x, so we kept that x. Here we know the time is 2, and so it's f of 2 plus h minus f of 2. All right, now this is very similar from here on out, from the last problem, at least until the end. All right, all the algebra is very similar. So this 2 plus h is going to go back all the way up here and get plugged into the t for t squared. So that's what this step is, 100 minus 4.9. And then the 2 plus h is right here, plugged in for t. All right. Minus f of 2, the second component of it, the 2 right here gets plugged in for t in this same equation. So it's 100 minus 4.9 times 2 squared. All right, and then we just got to follow along with our algebra. Again, don't forget your notation over here. Always write this, right? In this case, it's m equals. It's not 0. We're actually looking for m, or the speed in this context. All right, and so from here to here, we're just doing some algebra. The 100 minus 4.9 is there. The 2 plus h, right, is going to be squared, so it's just FOILed. 2 plus h times 2 plus h gives us the 3 terms sitting there. And then in this step, from here to here, is just we're taking the 2 and squaring it. 4 times the negative 4.9 gets us to here. All right, just bouncing back and forth. All right, again, notation, very important. This step right here is distributing the negative 4.9 over the 4h, and the h squared. And so right here, you've got the 100, which is just sitting there. And then when you distribute over the 3 terms, you get those 3 terms. All right. And then this next step right here is distributing the negative over the 100 and the negative 19.6. So you get these 2 terms, negative 100 plus 19.6. And I didn't highlight the h accidentally. Don't forget to carry your h all the way through. All right. I got to scroll that up. Hopefully that highlighted step was on the screen, but if not, I'll just repeat it real quick. From here, all we did is distribute the negative 4.9 down on these 3 terms, and here we distribute the negative times these 2. All right. Then the following step, we kind of combined a couple of steps, and we rewrote it with all of these terms that canceled. So the 100, the negative 100, the negative 19.6, and the 19.6. So this step going from here down is just a rewrite with the h factored out. So we kind of skipped a few steps in here and there, but as long as you can follow the algebra, it's fine. So the h is a GCF here after the terms are canceled. That's factored out here. And then the remaining thing is what's inside the binomial. And your h's here will cancel. So h over h will give us this next step. And then now we're at a very similar step in our previous problem in which we can go ahead and plug 0 in because the denominator, the h, is canceled. So 4.9 times, in this case right here, we just plugged in 0 for h, so that 4.9 or negative 4.9 drops out. And so you get the slope, or in this case, it's actually the speed, equals negative 19.6 meters per second. So do not forget, in this case, it's very important, do not forget your units. All right, so that problem's done. I really think you should go to the very top problem and read through that. It's not like this third problem, it's more like the second one. It's just the algebra is more complicated. All right, that concludes these notes or this video. Have a great day.